Hello folks. So in this video I'm going to finally add in a level to this game. Now I've previously made a level editor which I use for creating all of these. So you can see here I can load in the levels that I've been using for this game. And I've previously made a video that explains this, so I've got a tutorial on how I made this editor and I've attached the source code and everything for it. So you guys can just download that and make your own levels using it. So I'll put all that information and the links to that down below. But in the meantime, I'll first of all explain how these levels work before I actually load them into my game. So you can see that I've got everything split up into a grid. So there's a bunch of rows and columns. And that's essentially how this whole thing works. I've just basically split it into a map. And each of these tiles then within the map has a number assigned to it. So depending on what that number is, it correlates to one of these tile images. For example, I've used -1 for empty spaces. So all of these tiles that you see up here that have got nothing in them, they're just -1s. But then as soon as I get to something that actually shows any kind of item, well, those have a particular number and that correlates back to here. All of that information is stored in a Python list, which I then export into a CSV file. So I can show you the CSV file for this particular level right here. So you can see at first it just looks like a whole bunch of numbers, but actually it ties in exactly with this grid. So going down the way, that's showing how many rows I have, and then going across the way, because this can scroll, it just keeps going on to the amount of columns I have. And remember I said that -1 means that there's a blank space. Well, you can see there's a whole bunch of -1s here, which correlates with what I've got going on here. Now if I count down the way, I have 1, 2, 3, 4, 5 empty spaces, and then after that I finally have this dirt block. Well, that kind of ties in here as well. So I've got 1, 2, 3, 4, 5 -1s, and then after that I have a 0. So a 0 in my case correlates to this first button here, which is that dirt block, and so on. And that's basically how this map is all made up. So now what I need to do is take this CSV file, import it into my shooter game, and then process it in a way that correlates all of these numbers back into these images and converts it into something that the game can actually use for displaying and for creating collisions. So I'll start off with loading the data in first of all. So I'll close this down and get rid of this and just go straight back to the code from before. Now to import this information, because this is a CSV file, I need to load in this CSV module. So right at the top, I add in import CSV, and that's going to give me the functionality that comes with that. In addition, there's one more variable that I need to define within this game variables section. And this is my level. So I need to determine what level number I'm starting on. So I'll say level 1, and then as the game progresses, this level variable will increase every time the player finishes and moves on to the next one. A few other things I need to define are the number of rows and columns that I have within that level. I had 16 rows and I had 150 columns. So the level goes 16 rows down the way and then 150 tiles across the way. Now from this I need to determine my tile size. Now remember, this is a variable that I've used a couple of times without really explaining where it comes from. So now I'm going to explain that origin here. So if you notice, I have my screen width and my screen height, and then I have my rows and columns. So on the screen at any one time, I can only fit in 16 rows of tiles, and I know that this is my screen height. So to make sure that my scales are correct, my tile size should therefore be my screen height divided by the number of rows that I have. So that's going to evenly split the whole screen, or the entire vertical window, into individual tiles. Notice I used floor division here, and this is just to avoid getting a float value back here. I need this to be an integer. So now I can replace this tile size number that I had manually entered, and I have this calculated instead. The next one I need is tile types. So this refers to the different numbers of tiles that I had in the level editor. So if I go back to this and rerun that code, you notice I have a whole bunch of these different buttons. So in total there's 1, 2, 3 columns and 1, 2, 3, 4, 5, 6, 7 rows. So 3 by 7, I have 21 individual tile types. And that's why I have to define that variable in here. Now with this done, I can begin actually loading in the data. I'll go all the way down to the bottom of all these classes, and just above my main game loop, so in this section underneath my enemy group, I will start to load in my data. So first of all, as I mentioned, this information, this grid here, it needs to be able to store each individual tile position. So what I actually have is a list of lists. So each of these rows is one individual list, and then by combining all of those individual rows within one master list, I'm able to keep track of all of the individual positions. So to do that, I need to create empty tile list. And I'm going to call this world data. So to create an empty list, we just put in empty rectangular brackets or empty square brackets, and that just creates an empty list for me. But of course, I need to pre-populate it with something first. So I want to say that this list has a whole bunch of -1s in it. Remember, -1 means that there is nothing in that space. Now I've got my number of rows, so I've got 16 rows and 150 columns. So I'm not going to manually type out for each one of those. Instead, I'm just going to iterate through it. So first of all, I'm going to create an individual row. So I'll say R equals an individual -1 multiplied by the number of columns. So this will create a list with 150 entries of -1. So just to demonstrate that, let's print R. And I'll close this down, but you can see here, I have this list and that's just got 150 -1s in it. So that's created one individual row, but I have 16 rows. That means I need to iterate. So let's come up here and add a for loop. I'll say for row in range, and my range is just going to be the number of rows that I have. And then this line gets indented into it. So that means that I'll iterate 16 times, because that's how many rows I have, and each of those times I will create one of these long lines or long lists of -1s. And when I've done that, every time I've created one, I will add it to my blank world data list. So we'll say world data.append R. So if I was to now print world data, this is going to give me a very big list. So I can scroll this for quite a while, but you can see this is basically just a list of, you can see there's 2 square brackets, which is meaning that there's a list which contains inside it a bunch of other lists. So now I've got my world data, which at the moment has 16 by 150 entries, and they're all -1. So now I need to override all of these with my actual level data. So I'll add a comment to say load in level data and create world. To use the CSV module, I'll say with open, and then I need to give it the file name. So in my case, all of my levels are just named level 1 underscore data.csv. And then this number changes every time I move on to the next level. Now remember, I created a variable at the beginning called level, and at the moment level is equal to 1. So what I can actually do is replace this string in here with that variable. That means I can just keep increasing it or change that number whenever I want, and I will load the correct file. So I will put an F at the beginning of this string, and this is just going to use Python's string formatting functions here. So I'll do that and replace this 1 with curly brackets, and inside there I will put my variable. So this essentially takes that integer and then sticks it inside this string. After that, I will add a comma and say new line equals, and you don't put anything here, it's just a blank set of quotation marks, as CSV file. So now I'm opening that file and it's going to be prepared for reading. I need to create a CSV reader from it. I'll say reader equals CSV, which is the name of the module I've imported, dot reader. And in here, the file that I've just opened and I want to read has been opened as a CSV file. So I put that in here, and I need to specify my delimiter. So if you've worked with CSVs before, you'll be familiar with what the delimiters are. But essentially, this is going to tell me where each of these individual values changes to another. So basically, what is it that separates one value from the next one? Well, you notice there's just commas. So it's a comma that tells Python that this value is separate from this value. So by adding this delimiter, when it reads that CSV document in, it's going to know that every time there's a comma, it moves on to the next value along. Now I have to break that CSV file into individual chunks to be able to get it back into my world data. So first of all, I will split it into rows. I'll say for row in reader. And that's going to give me one individual row, which is going to look like this. And then from that, I need to extract each individual tile. So I say for tile in row. And now I can finally get my individual value, so I can change this world data list with it. So I can say world underscore data, and now I can put that number into the particular index point. But because I'm iterating like this, I have no way of counting where I am. So I need to know that, for example, as I go through this list and these numbers are being fed through, where within that list I am. So if I bring up this level editor again, for example, let's load in this level. Something that's over here is at grid point, if we're going by row first, it's row 0, 1, 2, column 0, 1, 2, 3, 4, 5. But I need to know that. I need to know that at 2, 5, I have this tile. So as I'm iterating, I need a way of counting where I am within the iteration. And you notice here I've got enumerate. That's exactly what I'm going to do within this loading section. So rather than just iterating directly through these, I will add enumerate at the start of them. So I'll put them in brackets, and I will add a second variable to this for loop. So I'll say for x, comma, row in enumerate, and then for y, comma, tile in enumerate row. Essentially all this does is that as it iterates, it also keeps a running count. So in this case, it's going to be x, and for this for loop, it's going to be y. And it just counts where we are within that iteration. So now I can use that information by saying x, y equals this particular tile. So now I know where within the grid system I'm at, and I can update that correct point in that list to the tile number. Now, the one issue here is that when you read in from CSV, as it goes through this, it's going to give me all these numbers, but they're actually going to come through as strings. So I need to convert them into integers. So I just say here, int tile. Now that should load in my data. So let's just check first of all that it's happened. I'll say print world underscore data. Now originally this was just full of -1s. So let's see if that's updated. And as you can see, it has. So it's reflecting what my level actually looks like. It's got all these different numbers within it. There's still a lot of -1s because it's just an empty space, but it's got a lot of individual numbers as well that correspond with particular tiles. Well, now that I have this information, I need to be able to turn it into something useful. So I'm going to create a new class. I'll come all the way back up at the top. So I've got my player class, and underneath the player class, I will create somewhere down here. Yep, I'll create a new class, which I will call world. Say class world, and this is not going to be a sprite class, so I don't need to add any of that information in. Then I'll put my constructor, so my init method, and it doesn't take any arguments either, so I don't actually need anything in here. And all that the constructor is going to create is one variable. So I'll put self.obstacle underscore list, and I will create an empty list for it. Now I'll explain what this obstacle list is in a second once I come to use it, but that is all I need for my constructor. Now the main method that this class is going to have is called def process underscore data. So this is the one that's actually going to take all that information and turn it into something that the game can use. This is going to take the argument of self and then data. This data is going to be that world data that I've just loaded in from my CSV file, and when I feed it into this method here, I can process it and convert it back. So the first thing I need to do is iterate again through all of that list, pick out each individual number and basically go through them one by one, and depending on what that number is, I take an according action. So let's begin iterating first of all. I'll add a comment to say iterate through each value in level data file. And I'll iterate in the same way. I'll have to use an enumerator because again, I need to know where I am within this list. It's not enough just to pick out the individual numbers. I actually need to know how they correlate to the position on the grid. So I'll say for y row in enumerate data. So that's that world data list. And remember, this is just going to then iterate through each individual row. So from that row, I need to again have another loop. So for x, tile in enumerate row. So now I'm going through that row and looking at each individual number, which is my tile. And here, remember, -1s meant that it was a blank space. So I can ignore all of those. There's nothing to process there. That means I should add a little check here that says if tile is greater than or equal to 0. So I only really need to process anything that is either 0 or above. The -1s are just ignored and we move on to the next value. Now that I'm looking at each individual value, I can figure out which image goes with that particular number. But before I do that, I need to load those images in first of all. So I scroll up to the top where I'm loading all my images. And above all of these bullets and the boxes and all that kind of stuff, I'll have a little comment to say store tiles in a list. So the tiles are those individual pictures for the dirt and the grass and the water and so on. And now because there's so many of them, I'm not going to load them in individually with one line for each. Remember there was 21 tiles. Instead I'm going to create a list. Say image underscore list equals an empty list. And now I can iterate through them. I'll say for x in range, and remember I defined a variable up here called tile types, so this is where that one comes in handy. I put in tile types, so because I know that I've got 21 different tiles, it's going to iterate through it that many times, and it's going to load the images in for me. So I load an image one by one. I'll say img equals pygame.image.load, and then I need to give it the location of the files. So in my case, I have a subfolder where this code is located called img. That's where I've stored all of my images. /tile. That's where I've stored all the individual tiles for this. And then within there, the tiles are just numbered from 0 to 20. So I haven't called them grass or dirt or player. They're just all numbered from 0 to 20. And the reason I've done that is so that I can use this iterator here to load them all in one by one. So remember what I did with the Python string format function there. I just add an f at the beginning of my string, and then I put curly brackets in here, and I can put that x in. So then I add x.png. And to demonstrate what I meant by those tiles, I'll bring them up here. So these are the tiles that I've got saved within the folder, and you can see they don't have names that correlate to what they are. They just go from 0 to 20. So by simply coding it like this, where x is changing at each iteration, it increases by 1, it means that I can load in all of those images one by one just by having this x within the string. So I can remove that now. So once I've loaded each individual image, I need to scale it accordingly. I'll say img equals pygame.transform.scale, and the item that I want to scale, type that wrong, is my image, which has just been loaded, so it's this img. And then I need to give it a size for x and the y scale in pixels. Well, I've already calculated my tile size, remember, so this calculation here tells me how big each of those squares in the grid must be. So I just put in here tile size for the x and tile size for the y, because it's a square. Now that each one is loaded, I add them into my list. Say image list.append brackets img. So by the end of this iteration, by the end of this entire for loop, I will have a populated image list with an image that corresponds to each individual tile. And with that done, I can continue loading them into this class. So I'll scroll down to this class world and continue working on this process data method. So where I left off was if tile is greater than 0. So if it's greater than 0, then that means that it must have some kind of picture. So then I can say my img, just for the purpose of this class, the img is going to be taken from that list, img underscore list, and then in here I put in tile. So remember, this tile is going to be a number, and that number corresponds to a particular image. So that's basically what this is doing here. It's pulling that image from that list. Once I've got the image, that on its own isn't enough. As I've kind of shown in the previous videos, all of these images need a rectangle to go with them, because a rectangle is kind of what handles the movement and the collision and where you put things onto the screen. So I need to take a rectangle from this image. img underscore rect equals img.get underscore rect. So that's going to create a rectangle for me, and now I need to give it a position. Well, that's easy enough. So I can say img underscore rect x. So I'll name the I'll assign the X and the Y coordinates of it separately. Now I have a way of counting where I am within my grid by using this enumerator here. So because I'm enumerating through my data, I know where I am when I get these numbers back. So by simply taking that number and then multiplying it by the size of each individual tile, I can give it an X position. I do the same thing for Y, so just change this to Y and this to Y also. And that's it. So by the end of this, each of those images that's been loaded in will have a rectangle that's positioned based on their point on the grid multiplied by the size of each individual square. So if the game window was to increase or decrease, if you were to resize it, then this tile size will change with it, so you're always going to have the same number of squares on your screen. So now that I have an image and a rectangle to go with it, I need to combine both of those together. And so I'm going to save that in a variable called tile data. And this is going to be a tuple, or tuple if you prefer. And that's going to contain my image and the image's rectangle. So this is the information that I'm interested in. This has now stored everything about that particular tile. And now this next bit is where I start to actually look at each individual one and say what they correlate to and how to process them. So if we come back to the level editor, I'll run it again. Now notice that the first 9 tiles are different types of earth. So these are something that the player could collide with. The player as well as the enemy, they will collide with them. So these are obstacles. The rest of them, well, water, for example, isn't an obstacle. That's something that will kill the player. And then these stones and box, the other stones and grass, they're just decorations. That's the player, that's the enemy. And then these are those pickup boxes that I created previously. And then lastly, this is the exit that will take me to the next level. So actually, although these, as far as images, are easy enough to load, they have different functionality. So I need to handle them separately with their own statements. But I can handle the dirt first of all. So these first 9 items are all going to be my obstacles. And this is why I created this obstacle list. It just means that when I eventually come to coding in the collision, I don't need to check for absolutely everything in the world. I just need to check for the dirt blocks, so my obstacles. So that's why I've created this separate list to speed up the collision checking later on. I'm only going to be looking for collision with anything that's in the obstacle list. So in here, I can now start checking for individual numbers. I'll say if tile is greater than or equal to 0, and I like to leave a space there, and tile is less than or equal to 8. So remember, this is from 0 to 8 are all of those individual dirt blocks. Well, then those are all obstacles. So I want to add them to the obstacle list. I'll say self.obstacle_list.append tile data. And this tile data is this tuple up here that contains the image and the rectangle of it. So now my obstacle list, by the end of this entire iteration, once I finish this process data method, it's going to fill up with all of those dirt blocks. So I'm going to know exactly where they are, how big they are. And the next 2 blocks after that were water blocks. So I'll do another check here, elif, which is else if. So if it's something different to this value here, then we move on to the next check. Say if it's greater than equal to 9 and also less than or equal to 10. So I guess I could just say if it's either 9 or 10, but it's just the way I've done it. Then this section is going to be water. For now, I'm going to pass, and I'll just add a comment to say water. Next, elif tile is greater than or equal to 11, and tile is less than or equal to 14. So these are all those decorations. Now those were the box, the wooden box, the pile of rocks, the grass, and so on. Again, I'm going to pass these because I need to create additional classes for those. So we'll just say decoration. Next one is elif tile equals 15. So 15 was my player. Now remember previously, if I scroll down to here where I was creating my instances of classes, I was just manually typing it out. So I manually created a player here and I created this health bar, same for the enemies. I don't need to do that anymore because my world data, again, I'll just quickly show you my level data here. If I load level 1, it has a player here and then it's got enemies. So I can put down these enemies wherever I want to. I can make as many of them as I need. So I don't need to manually create it anymore. when I'm reading and processing the level data, it's going to tell me there's a player here, so create a player instance. There's an enemy here, so create an enemy instance. So that means that I can get rid of this code. And for now, I'll just copy it out of there and move it up into my world class and just continue processing it. I'll just dump it here for now temporarily so I can copy and paste it. So what I want to do when I get to tile 15 is create a player. And that's going to be in the exact same way. I can just copy this code, put it in here, make sure it's indented properly, and it's going to create a player for me. But note, when I was creating them previously, I had these coordinates manually defined as 200 and 200. That's no longer the case because it's going to vary depending on the level. Well, now I have these x and y variables that determine its position on the grid, and I have a tile size which shows me how far away each tile is. That means I can just say his x coordinate is equal to x multiplied by tile size, and the y coordinate is y multiplied by tile size. The others, they should stay the same, so that's still scale, speed, ammo, and grenades. So those don't change. And then I create the health bar, so that also stays the same. So that handles the player, and we'll say elif tile is 16, and this one is create enemies. So again, I just copy this up, and actually that had 2 enemies, so I can delete one of them because I only need to create one at a time. So let's delete that and delete this one and indent this properly. So now I'm doing the same thing. I'm creating an enemy this time, and again the x and y coordinates are going to be determined based on the position on the grid. So we change that. But then of course when I've created the enemy, I need to remember to add them to the enemy group. So that takes care of those ones. I carry on with the next elif statement, which is tile is 17. 17 is, so these next 3 are going to be my different drop boxes. So tile 17 is an ammo box. So create ammo box. And again, remember I did this manually. So let's go down to where I was creating these instances, just in here. Remember I even called them temporary. So I can remove all this now. I'll just copy it out and come back up and start to put it in here. So this 17 is an ammo box, so I'll just copy this, put that in there, and just make sure I indented it correctly. So I'm creating an ammo box, or an item box, which is ammo, and again, coordinates. Well, I'm going to use this for every single one of them, so we just put that in here. So that's it. That will create my ammo box, added to my item box group. Next, I know this is probably getting a bit repetitive now. Just copy this down for 18 and 19. Delete all this. So 18 is my grenades. So we just change this to grenade. And 19 is health. So we just change that to health. Okay, and last one, I only have one more. elif tile equals 20. So this tile is my exit. So we'll say create exit. And I'll have to pass again for now because I don't have that coded in yet. Alright, so that is the method almost complete. The only thing to notice here is that I'm creating a player instance and a health bar instance within this method. So they're going to be local. I'm not actually going to be able to access them inside the main game loop. To be able to do that, I need to return them from this method. So at the end of this, I need to add in a return statement. So we'll come down here and oops, indentation has to be around here. So let's just make sure that lines up. Yep, so it's indented within the method. And I just say return. And what I'm returning is that instance of the player and that instance of the health bar. And that's it. The method is complete. So now let's call that method to actually run it. Come back down to where my instances are. And here, remember, I've loaded in my, I've created my empty list. I've loaded in all that data. Now I need to make sure it's being processed. First of all, I'll create an instance of the class. So I'll say world equals world. And now I can call that method. So the method was called process data, and it belongs to the world instance. So we'll say process data. And remember, the argument it took was the data itself. So in here, the argument is world data. But also note that there were a couple of returns. So I was returning the player and the health bar. So I need to take these back out of here. So I'll say player, comma, health bar, oops, not health bar. Health bar equals that. So when I get these returned, I'm going to end up with a player and a health bar. Even though I haven't created them separately as instances, it was going to return them this way. So that was quite a lot of typing. I'll run it just to see if anything works from that. And it did. So that worked exactly as it should have. So you may not have immediately noticed any major difference, but remember, I didn't manually call a player instance, nor did I call manually the enemy instances. These have been created from that world data. So they've been positioned based exactly on what the world data contained in it. The problem is that nothing is actually being shown from the level, and that's because all I've done is load it in at the moment. I don't have any blit methods or blit functions being called. So I have a process data method, but I don't have a way of drawing it. So underneath all of this, I need to create a new method called draw, and this is just going to take no arguments for the time being. And now all I need to do is iterate through my tiles again. But remember, I'm not going through all of them. I'm only going through the obstacles for the time being. Those are the ones that I want to show on the screen. So I say for tile in self.obstacle list, I iterate through each one of those. And to show them on the screen, it's just as I've done before. You call the game window.blit. And now I need to blit the image followed by the image's square. Well, remember that tile is actually a tuple, and within the tuple, the first value, or value 0 at index 0, is the image, and index 1 is the rectangle. So I can extract that in the same way. I can just use the index positions. So for that tile, index 0 is going to be the image, and then I need a rectangle. Well, that's tile 1. And that's it. The draw method is finished. So let's go down to my main game loop. So here I'm drawing my background. Actually, I'll add a little comment to it to say update background, because that function will grow. And next I say draw world map. So I've got my world instance and it has a draw method. So I call that, run that code, and now you can see I've got my level loaded in. So the player at the moment, remember, I don't have collision or gravity working properly. Well, sorry, I do have gravity working properly, but it's taking this line here as my floor. So I don't actually have a way of interacting with the level yet, but you can see it's starting to come together. I'm actually showing it and it's drawing up properly. So now that that's starting to come together, I want to go back up to that world class, and I just want to address the ones that I've missed. So I skipped over water, decoration, and the exit. They're actually really easy to add in, so I'm just quickly going to do that now. So just underneath the world class, I'll create a new class, but I can just copy what I've got for my item box because a lot of it's going to be the same, or at least the first few lines. I'll just copy the first 3 lines, put them in here, and I'm just going to change this to decoration. So it is going to be a sprite, or a PyGame sprite class. So I keep that, I keep this, and I keep this line as well. Then the next thing, one thing I do need to change is the arguments. The argument that I need here is the image. So these decorations could be different things. So it's the little boxes or grass or rocks. So that's what's going to determine which one. And then the X and Y stays the same. That's just the coordinates on the map that I need to draw them. So after this, I just need to assign those to self variables. So let's say self.image equals img, and then self.rect equals self.image.get_rect. So that creates a rectangle from it. And now I just need to position that rectangle on the screen. So I'm going to define it based on the mid top position. And here, remember, I've got my X and Y coordinates and I have my tile size variable. So I'm going to say X plus tile size, and I need to half this. The reason I'm halving it is because I'm positioning it in the middle of the grid. So this is the middle of the square. So I'm going for the midpoint. And now for the Y position, I say Y, which is my grid position, added on to the tile size minus the image's height. Self.image.getHeight. And that's it. So that creates my decorations. I just need to make sure that I actually call them from this section here. So I can get rid of this line, and I can pretty much just copy one of the other ones, like item box, for example. I can just copy that in here, because the code is the same for the first 9 instances, or for the first 9 tiles. What I was doing is actually processing them and saving them in a list. But for pretty much all the rest of them, I have classes existing. So this just triggers to create instances of those classes. So here I change this to decoration. And I say my decoration is an instance of the decoration class. The image it's going to take is img. Remember, img is being loaded in here. So it takes that image, and then the x is just the same as I had before for all the rest of them. X times tile size, y times tile size. And then I need to add it into a decoration group. I haven't made this yet. I'll make all these groups at the end once I've added this code in here. So just change that to decoration. And that's it. So now when it gets to these tiles, it's going to create a decoration. So the next one I want to add in, let's go down here, is I believe water is probably a good one. And I think water is pretty much going to be the same. So I can copy this decoration class down, just change that to water. And it takes the same arguments. So image, X and Y, this stays the same. Get the rectangle, so that section stays the same. And I believe even the positioning should stay the same. So that's my water class done. And then the last one is exit. So I'll just copy this down again, change that to exit, and then just keep all the rest exactly the same. So maybe I could have had a single class to handle all of these, because the code pretty much is the same at the moment. However, the reason I've split them up is because the way the collision is handled with them is going to be different. So decorations are not going to get in the way of the player at all. They're just going to be there. Water will have collision, but it also has a consequence which will kill the player. And exit has collision, and the consequence is that it moves on to the next level. So although they have the same code for now, they do have different actions and outcomes, which is why I've separated them just to keep it a little bit more logical. So I just need to make sure that I handle them within here. I'll just copy what I did for decoration into this section, which was water, and I'll replace this with water, change the class name, and change the group name. So that's those done, and just right at the bottom, the last one was the exit. So just do the same thing again, change these, change the class name, and change the group name. So remember, I'm not having to change anything else, like the image or the position. That's all determined by this tile when it's being loaded in the first place. All right, now I can't run this just yet, because remember, I've just called all of those groups, but I haven't created them yet, so I will get an error if I try to run that. So I need to make sure that down here, I add those extra groups. So enemies, bullets, grenade, explosion, item box. So after that, I'll add my decoration group. Then I add in water, and lastly I add in the exit. So again, if I run this, it will run, no errors, but nothing is showing up. And remember, that's because all of these groups have to have their methods called within the main game loop. So I've got this big section here, and I'm just going to keep adding to it. So let's add in underneath item box, I want my decoration group updated. At the moment, it doesn't actually have anything in that method, but I will add that in later, so I may as well just add this in at this point. So next is water, and then the last one is exit. So let's change that. And now I do the exact same thing, but now I have to draw them all. So copy that down, and again and again. So we change this one to decoration, change this one to water, and then change this one to exit. All right, so now if I run this code, it's working. You can see I've got my tiles, but I seem to have done something wrong because they're floating on top of the tiles instead of sitting on the bottom of them. So let's address that now. It must just be the way that I've positioned them. Let's see, did I send in the wrong X and Y coordinates? Oh, I see what I've done. Instead of putting tile size, I've auto-completed to tile types. So let's just start here and make sure I catch them all. So that's supposed to say tile size. Same for this. And yep, made the same mistake here because I just copied them all down. Okay, that was pretty silly. Let's run this again. And there you go. That's working a lot better. I've got all of these little decorations showing up on top. I don't have any scrolling coded in just yet, which is why we can't continue over to the right hand side of the screen and see the water and finally the exit right at the end. But the fact that these are working suggests that all the rest of it is working too. And that's it. That's the level basically loaded in. So what's left to add still is the scrolling as well as collision, which I'll do in a future video. For now, I realize this video has become quite long, but I just wanted to go through it in detail because it's a difficult topic, I think, to explain. So I just want to make sure that I explain it all thoroughly. So if you found this useful, then please do leave a like. And if you want to stay up to date with these tutorials, then feel free to subscribe. Thanks for watching.